I'm Lucas Moser. This is Eric Dowley. Today we're going to be covering MongoDB. What is it and how does it fit into business intelligence? Before we get much into MongoDB, I want to talk about just technology disruptors in general. So what was it, late 80s, early 90s, Linux came onto the OS scene, and it's basically came on because Linus Torvald recognized a need within that space, a need for operating systems that were accessible, that gave the user a fair amount of control, and that could run inexpensively on the hardware that it needed to. Linux was all set to just completely take over the world and make everything else obsolete. So as time went on, obviously, I mean, we end up with Linux operating systems in our pockets. It's running most of our web servers. But at the end of the day, as we look around, we are still running Windows servers, and we're still, running Windows on our desktops. So one thing I want to address about technology disruptors before we get too deep into MongoDB is that they don't always completely displace the applications and the tools that were there before. Quite often they work alongside and they become a toolbox in that tool belt. And that's actually a lot of what we're tending to see with MongoDB. So rather than framing this conversation as how is MongoDB going to take over the world, instead, let's consider it as a tool within a toolbox and recognize what it is good and not for. Let's start out with what we really know, which is relational database systems. As data managers, as business intelligence professionals, I mean, this is really what we've made our bread and butter on. Everything has tabular structure, obviously, with tables, rows, and columns. We know about normalization, making modifications to a data model, to an ER diagram, so that we can avoid, update, and insert and delete anomalies. We know about foreign key constraints to help drive data quality so that we don't have orphan data. All of these things help drive quality of data, which really, at its core, is what relational databases were built to begin with. They were intended for accounting systems, things with high transactional effectiveness. And the query language actually itself, the SQL query language, is incredibly powerful and incredibly ubiquitous too. I mean, given the fact that there are so many different database systems out there that run relational schemas, the language is surprisingly consistent. And so because we know these so well, we often find that we can bend the rules. So if we're looking at a relational model, if we're looking at a relational database, and we're familiar with this space enough, we know that we can denormalize data. So if a query isn't performing as we need it to, and it's not performing, let's say, because we're doing too many joins, we know that we can denormalize that data, bring it into one table, and often improve performance drastically. Obviously, because again, we know what we're doing, we know that we have to then handle those update, delete, and insert anomalies on their own. But that's a trade-off that we're willing to make if we understand those rules. The same thing goes with XML and JSON fields. Often we want to store structured data within a particular column within a relational database. We know that we can't query that data. We know that that data isn't properly normalized. However, we also know that if we want to go pull all of that data within that field at one time, quite likely based on some sort of key, we know that is incredibly fast. But again, this is not what relational modeling is really built to do. I've seen lots of cases in the past where data managers will forego foreign key constraints in a production environment. And the same thing applies. We know that in a dev environment, we need those things in order to drive good data quality. But in a production environment, sometimes we'll forego them in order to get better performance. So as I was thinking about this, I was thinking, this man in this car clearly understands physics well enough to drive this thing on two wheels. He's done it before. He's done similar things to it, and he's prepared to make this decision. However, at the end of the day, if we really want to drive on two wheels, we might be better off with the motorcycle. And if we really want to denormalize our data, if we want to store structured data in a flat manner with XML or with JSON, we really might be better off looking at MongoDB. So why was MongoDB created? Largely for developer productivity as well as distributed systems. So with regard to developer productivity, dev cycles get really long when developers have to constantly go back to DBAs and say, hey, we need to add this field, or we need to change this table structure, or this query is performing slowly, we need another index. Some of those things can be avoided if, as database administrators, we put more responsibility and more ownership of that in the hands of the developers themselves, which sounds like a less control sort of situation, but it is much more control for the developers. This gives them the ability to evolve their model more rapidly and make it more closely reflect actual things in the real world. For example, one of the things we see come up a lot in MongoDB is it's used for a user profile database. User profiles oftentimes have, maybe 10 or 20 different tables that we're trying to join to pull all of that data back. Well, a user profile isn't necessarily a relational thing. A lot of times it could very logically and more clearly be structured as a document. And so we see that type of application of MongoDB quite often. Also, with regard to horizontal scaling and data governance, these things are built into MongoDB to start with. Now that doesn't mean that relational database systems can't do these things, but yeah, they were built in to start with. It was a focus from the very beginning. And if you're interested in reading more on that, I had a very interesting article here from one of the co-creators of MongoDB, providing some more detail on that, but I don't want to get too deep into it today. So let's shift into MongoDB a little bit. So instead of having tables, rows, and columns, what we have is a document structure. So within that document structure, we have collections, which would essentially be the table itself, the documents, which would be the row, and the properties on those documents, which would be the columns. Now, within each one of these collections, we don't necessarily have to store the same thing like you would in a table. We can store heterogeneous data types. So if we need one document within one collection to have 7 properties and the next one to have 12, that is not a problem, and it's actually built in by design into the MongoDB data modeling. Also, because again, it is a different system with different constraints, we do see increased speed and scalability. But of course, this only really follows under certain circumstances. I mean, you don't get everything for free, and just because you're using MongoDB doesn't necessarily mean it's going to be faster. However, if you're using it for what it's intended to, if you find yourself in a relational database model where you're wanting to do things that aren't really relational, you very likely might see some speed up and some scalability by switching over to MongoDB. And the next thing I want to cover, and we'll get in more detail on this in a second, is we're more or less leaving SQL behind. And that doesn't mean that you can't use SQL. Eric will cover a little bit later about how you actually can use SQL to query MongoDB. But again, it comes down to using the right tool for the job. So if you find yourself wanting to use SQL again, maybe MongoDB is not the right solution, unless, of course, you're trying to connect into Cognos, which is exactly what we'll be covering in just a bit. So let's stop for just a sec and take a look at development within MongoDB. How do we interact with it? How do we kind of cover some of our day-to-day tasks that we're trying to make work within MongoDB? MongoDB has 2 query syntaxes. The first is the find syntax. So this is the equivalent of select. It was the first syntax that came out. It was a little bit restricted. Really, all you can do is select from with a single table. You can't do joins, as well with the where. And then, of course, top and limit in order you can follow on behind that. The aggregation syntax, however, was a much later syntax that came along. You can do all the things that you would typically find in a find syntax. However, that's when they introduced left outer joins, group bys, and havings. So let's kind of dig in a little bit to both find syntax and aggregation syntax. I don't want to go too deep today. This is not a primer course on how to write finds or aggregates. However, what I want to show you is what the query language looks like so you can get a general overall feel and start to see what some of these results might look like coming out of MongoDB. So the first would be the find syntax, which again really just covers basic selects with basic wheres from a single table or a collection in the case of MongoDB. You can apply your filter. You can do projections, which would be the equivalent of what you include in your select statement, in the select portion of the statement. Sorts, limits, and then pretty basically goes through and prettifies or formats all of your output for you. So aggregations are a little bit more powerful in the sense that they start to introduce the idea of grouping. Obviously, the halving comes with that as well. And this is also where more recently, in more recent versions of MongoDB, the idea of a join was actually introduced. What we can see here is the aggregation pipeline, which is, if anyone's familiar with the pipe and filter mechanism, this is actually what it's built on. It takes the events from the events collection and runs them through a pipe and filter mechanism to produce an output. So in this particular one, we have 4 different stages of our aggregation pipeline. We're doing a match, a group, a match, which is more or less a where clause, and then finally a sort. So the data then gets run through these and then spit out the other side into the results. So working with expected features within MongoDB. Within MongoDB, you have explained query plans much like you would in SQL Server with estimated execution plans, or much like you would in Postgres with explains, or MySQL with explains. They essentially do the same thing. They're going to give you feedback on how collections are scanned and whether or not indexes are used. They're particularly useful, however, they are a little bit limiting in the fact that you don't necessarily get access to everything that happens. So in the case where maybe there's a lookup, a join within your MongoDB aggregation pipeline, you may not necessarily get access to all of the query scans, all the index scans going through that. Speaking of indexing within MongoDB has multiple data structures that you can use, whether it's hash, geospatial, or text. You can also index at multiple levels within the document, so a multi-key index. So if you have one document and that document has a subarray within it, you can index into that subarray, which of course is very powerful. However, if you want to start going multiple levels deep, if you want to start going into some sort of recursive document that has a dynamic levels of depth, it does not cover that. So that's just something to keep in mind there. Also, much like we would see with tracking data types or tracking check constraints within a relational database system, we also can do schema validation within MongoDB. This allows for validation of data, whether it is checking types as you put types in, whether it is checking to see if a string is within an accepted range of values, things like that. Also, most importantly, transactions have been supported within MongoDB for quite some time. I think actually from the beginning, if it's a single document transaction. However, most recently in version 4.0, they introduced multiple document transactions. So if you're using the Wired Tiger storage engine version 4.0 and you're using replica sets instead of sharded clusters, you actually now can do multiple document transactions and have those persisted to the database. With that said, I think that covers more or less a history and a background and an introduction to MongoDB as a database system. And so at this point, I'm going to go ahead and hand it over to Eric Daly, who's going to be covering the MongoDB to Cognos integration.
All right, thanks, Lucas. My name is Eric Daly, and I'm going to be showing you how MongoDB fits into business intelligence. More specifically, I'll be talking about the process of connecting Cognos to MongoDB as a data source, so you can use MongoDB data in your reports and in your visualizations. First, I'll describe the process of connecting MongoDB to Cognos. This first section is kind of an info dump, so you'll be able to reference it later. Then I'll be giving you a demo showing you exactly how to do the connection to Cognos. This process actually took a bit of research. There aren't really any resources online detailing exactly how to get Cognos and MongoDB to talk to one another. So this is a real treat for everyone here at Bacon. Again, we'll be providing these slides and this presentation after the conference for your reference. So BI tools typically only speak the language of relational or sometimes the language of dimensional. Well, on the other hand, we have MongoDB, which is a document database and therefore only understands NoSQL. What we need is something to act as a bridge between these two worlds, SQL and NoSQL. And that's where the Business Intelligence Connector comes in. The BI Connector is an application that sits in the middle and translates between SQL and NoSQL. This BI Connector works with many BI tools, Qlik, Power BI, Tableau, etc. But most importantly for everyone here at Bacon, it works with Cognos. So there are two main ways to set up the BI connector infrastructure. You can install and configure it yourself locally if you have a local install of MongoDB. Or if you're using a cloud service such as MongoDB Atlas, you can have them handle the installation. MongoDB Atlas is a cloud service administered by MongoDB, the company behind MongoDB. For the purpose of this demo, we'll be using the BI connector with MongoDB Atlas. Though if you want to know more about installing the BI connector yourself, I do include a link to an easy-to-follow guide later in this presentation. Just to reiterate the overall structure, we have Cognos, which connects to the BI connector using a MySQL connection and a JDBC driver. The BI connector then translates that into MongoDB's query language. So essentially what Cognos sees is MongoDB data converted into a tabular format that it can understand. And in this case, the BI connector exists on the MongoDB cloud, so it doesn't take any special configuring to get working. First, you need to turn on the BI connector. Turning on the BI connector is very easy. It's just flipping a switch. Cloud cluster will increase depending on your level of usage, but it's usually very small. If you install the BI connector locally, then there's no increasing cost. The BI connector itself is free. Step 2 is connecting the BI connector to Cognos. You'll need to place 2 drivers in your drivers directory. Usually it's something like IBM Cognos / analytics / drivers. You'll need a MySQL connector Java version 5.1.46. You'll need that exact file because newer versions of the MySQL driver will not work with Cognos. You need 5.1.46 exactly. And I include download links later. If your MongoDB server is using authentication, and it almost always is, or at least you should be using authentication, you need the MongoSQL auth file, the latest version. You need the latest version, not specifically 1.1.0 as is laid out in these slides. That's just the most recent right now, but when a new update comes out, you can use that and it shouldn't cause any problems. So next is adding the connection. You'll want to add the data server connection by going to Manage, Data Server Connections, Add, and search for MongoDB. It's officially supported as a few Cognos versions ago. If you don't have access to data server connections, you just need to talk to your Cognos administrator. So for formatting the connection string, you have a few different parts you need to consider. Server is the domain name or IP address of the server. Port is the port that the BI connector is listening on. The question mark use SSL is for whether you're using SSL or not. True if you are using SSL, false if you aren't using SSL. Chances are you will be using SSL, so you'll want to use true in that part of the string. And the last part in purple here is the authentication string. Use this exact string if you're using authentication and have the authentication driver. This just tells the connection string to use the authentication driver you have. Now, when configuring the sign-on, you'll need to provide a username and password for the MongoDB server you're connecting to. You'll also need to append $source equals admin to the username, not just the username as you're used to. Admin is a default authentication collection in most MongoDB instances, so that's why you add that admin there. If your authentication collection has a different name, you'll need to replace admin with the name of your authentication collection. So now you have everything entered. You need to test the connection. You should get a success indicator and the message to the right, and this message to the right in the test results. You can now create a package or data module off of the data source and start exploring your MongoDB data. Some pitfalls I ran into while researching this process is that Cognos needs to use a JDBC connection instead of an ODBC connection. Most resources online reference using ODBC instead of JDBC. You'll also need the exact correct MySQL driver, which you can get the download link from this next upcoming slide. So here are some download links for you to reference later. We have both necessary drivers. as well as links to the BI connector and to MongoDB Atlas. All right, so you got a quick explanation and kind of an info dump for your reference later. Now it's time to show you a demo and for you to see things in action. I'll walk you through the steps of setting up the connection between Cognos and MongoDB, starting with activating the BI connector, then installing the correct drivers, connecting Cognos to MongoDB, creating a data module off of that MongoDB data connection, then creating a basic visualization from the data module using zip code data. I've already loaded the zip code data into MongoDB for us to use. All right, so let's get into the demo. Okay, so the first step is you're going to need to activate the BI connector inside your Atlas environment. For the purpose of this demo, I'm going to use Atlas due to time constraints and because it's the most straightforward way for you to start using MongoDB and Cognos. Atlas is free at a certain performance tier, so you can start getting your feet wet and start playing with it. Activating the BI connector will cost a little bit, but it's not very much at all. So in order to activate the BI connector, you have your cluster here. I created this bacon cluster. Just click on these ellipses, edit configuration, additional settings. You can see the different settings I've turned on. Just keep scrolling down. And turning it on is as easy as flipping this toggle to the yes position. As I said, it will increase the costs by a marginal amount, but it's really not that much, especially if you just turn it on when you want to play with it. And then to get a feel for it, then turn it off when you're done. It won't cost very much money at all. So we have it turned on. Now the next step is to ensure that we have our driver files in the correct directory on our Cognos server. So here I am. I'm remoted into our Cognos server that I'll be showing the visualizations on later. And let's see here. Yep, we've got my MySQL connector Java jar driver file. All right, and then we have this MongoSQL auth file for the authentication to work. And if once you copy this in here, you'll have to restart your Cognos server, but that's standard. That's not different than installing any other driver. All right, so now we have the BI connector up and running through Atlas. We have the driver files where they need to be. Things are all ready to go. So now let's open up Cognos and connect Cognos to the BI connector. Okay, so here's our Cognos environment. What we're going to want to do is go to Manage, go to Add New Server. Now, if you don't have access to this, you can either request access from your Cognos administrator or have them do this for you. Search for Mongo. There we go, MongoDB connector for BI. Oh, there we go. First, let's set up our JDBC URL, our connection string. So we have JDBC, MySQL, because as I said, Cognos uses MySQL to connect to the BI connector, which does the translating into MongoDB language that MongoDB can understand. So first we have this host and port. Hold on, let me copy that over for you because I have all this saved. See this part, host and port. Let's just paste that in there. And if you're using MongoDB Atlas, you can get this information very easily. Just go to your cluster, click connect, and connection info will pop up. All right, so for SQL import, we have for the server import, we have the server, we have the port. This database part isn't relevant for when connecting to MongoDB, so you can just delete that. Then since we are using SSL, we need to include this part as well. Question mark use SSL equals true. And then since we are using authentication, we do need to include this string at the end of our connection string. So this add authentication plugins equals org.mongodb, yada, yada. That's just telling the connection to use the authentication driver that we have. And this will be the same for any environment. So you don't have to customize this part. You can just copy and paste it from the slides from earlier. Okay, now we have the JDBC URL set up. let's set up a sign-on. All right, so let's add a sign-on. Let's name this Bacon MongoDB creds. For a username, let me copy it over. All right, here's our username. All right, so I already set up the username and the password within MongoDB. So we can just use the username that I already created. So Bacon user, and then we have that @source equals admin because admin is the name of the authentication collection within MongoDB. All right, so that's our username and string at the end that we need to include. Let me copy over the password. Right there, right there, right. There we go, we should be good to go. Let's test this and hopefully it will work. Yep, it works. So once it works, you should see this message here telling you the different steps it took, and it's using the MySQL connector Java to connect to the BI connector. Right, so the connection worked. All right, let's name our new connection. Let's see, what should we name it? Mongo Bacon data source connection. There we go. So let's save it. There we go. It's saved. So they have the data source connection created. Let's create a data module that we can build off of that and then report off of once we have the data module created. All right, so let's create a new data module. Let's see, our source needs to be a data server. Let's see, Mongo Bacon data source connection. That's one we want to use. There we go. So it's not showing anything here. And just like anytime you create a data module, you need to go to Manage Schemas. Here are the schemas. Zips, we're going to be using zip code information that I already loaded. It's a really simple data set just to show you how the connection works. So here's the zips. All right, let's load the metadata. And this isn't just for MongoDB. This is the same for creating any data module. Okay, so it's been created. All right, there we go. Now we're seeing zips. Let's select that. Okay. Done. Now we have our new data module here. Oh, there's a new data module. Let's connect zips in there. All right. We have zips loaded with data. Yep, no validation issues. We can see they're connected. So let's save this. Let's see, let's save as Bacon Mongo. Bacon Mongo data module. There we go. Let's save. All right, there we go. So now we have our data module created that's using the data source. So let's now create a dashboard off of it so you can see the data in action. All right, choose this. Once again, this is a very basic data source, so it won't be all that complicated, but you will be able to see that we are using data from MongoDB, and you'll see the whole process. And you can recreate this later if you want to play with your own MongoDB data. All right, so let's add a data source. Let's find the data module we created. All right. All right, so we have zip codes. Let's do something real simple. So let's just do a map of states and their population. All right, let's let it load. And there we go. States and their population. Very basic visualization, just showing that we've gone through the whole process from MongoDB and everything's flowing through, and we are now reporting off of that data here in Cognos. So there you go. With more complicated data, you could do more. I just wanted to show that the whole process is working, and it's possible to connect Cognos to MongoDB. And that's all for this presentation. I thank you for your time. If you have any questions or anything like that, feel free to contact us at PM Square. And I hope you have a nice day. Thank you.